Chemical bonding. Here are some important formulas and the concepts of chemical bonding. First of all, we need to know about the number of stereoisomers, which are mainly 2 raised to n. Second and the most important thing, which is asked mainly in the JEE mains examination and MHT-CET, is the hybridization. I have two important formulas of this hybridization. Let us start out with the first. Let us say hybridization H is equals to half of monovalent plus valency minus of cation plus anion. And second formula which I have is hybridization is sp3 minus pi. The third is how to calculate the bond order. Bond order formula is mainly sigma plus pi by sigma, or the most important which is widely used is number of bonding minus number of anti-bonding divided by 2. Let me tell you about the Fajan's rule. Through this Fajan's rule, we need to calculate that which is the most importantly the covalent character and the ionic character is dominated by which and by how much. Like, we have to remember some tips, like wherever the cation is smaller, anion is larger and the charge should be higher. Now wherever these three categories we will be able to see, there the covalent character is seen to be more. And since wherever this characteristics is not followed, that is the ionic character is followed in that particular case. One trick of bond order is this. You can directly learn the bond order of starting from down. 18 is 1, then 1.5, 2, 2.5 and 3. Where this column is of the bond order and this one is the atomic number. Like if we have oxygen is 8 to the 16, so for 16 its bond order would be 2. One more thing, if we have to find the hybridization through the sp3 minus pi rule, it's like this. If I have this structure, so for firstly this carbon, applying sp3 minus pi rule, here sp3 minus 1 pi bond is there, so it will be sp2. When consider this carbon, here is sp3 minus 2, sp. Same for this sp3 minus 2, that is 1. And if let us say here one more carbon is there like this, so this carbon will be sp3 minus 0, that is sp3. One trick you can remember for paramagnetic and diamagnetic. Here one exception is there, 10 and 16. Paramagnetic has odd number of electrons, while diamagnetic has even number of electrons, except 10 and 16. These are the diamagnetic, but they act as paramagnetic. Through this, we will be able to find out that whether the given molecule is paramagnetic or the diamagnetic. Similarly, I have one more thing about dipole moment. Since this dipole moment is of two types, one is polar and one is non-polar. Wherever the mu is not equal to 0, it is the polar one, and where the mu is equals to 0, it is the non-polar one. I have the trick for this. When we find a hybridization, lone pair plus bond pair. If you see the bond pair to be 0 in any of the cases, here will be any number or the combination of this 2, 3 and 4, 2. It's considered as non-polar, and except this, all are the polar one. Since this dipole moment, it can be written as mu and it is equals to q into d. Let us learn now how to find out the geometry and the shape. For sp, we have 2 plus 0. Here this 2 is the lone pair and 0 is the bond pair. So for this particular case, for sp, we have bond angle to be 180 degrees. And this is the linear shape it will have. Next is sp2. Here the angle is 120 degree. Combination is 3 plus 0. That is the trigonal planar shape. Next is sp3. Bond angle is 109.28 seconds. Here it is 4 plus 0. That is the tetrahedral. 3 plus 1. That is the pyramidal. 2 plus 2, which is bent or angular. And 1 plus 3, that is the linear. Next is sp3d. 5 plus 0, trigonal bipyramidal. 4 plus 1 is seesaw shape. 3 plus 2 is T shape. And 2 plus 3 is linear shape. Next is sp3 d2. 6 plus 0, octahedral or square bipyramidal. sp3d2, 5 plus 1, square pyramidal. And 4 plus 2, square planar. The last one is sp3d3, which is 7 plus 0. We can call it as pentagonal bipyramidal, or we can also call this distorted or capped octahedral. One thing to remember is lone pair is greater than lone pair bond pair, which is greater than bond pair.